Hi everyone. So today I'm bringing some most important questions and theorems. So please be focused and watch the whole lecture. And this question is from the last lecture. And in that lecture we did some minor mistake. And today we will solve it again. Say this is a question from the transformation of a chi-square distribution basically. So we are given with a continuous random variable with PDF like this. Then find the distribution of W is equal to 2x square. W is equal to 2x square. So see, let's transform this. That's W is equal to 2x square. So W by 2 is equal to x square. Let me tell you the formula for transformation. That's f of new function, that's f of new is equal to f of old function into Jacobian. Say this is under root w by 2 is equal to x. So 1 by under root 2, 1 by this is under root w is equal to x. Now differentiate with respect to x. So this is 1 upon under root 2 under root 2w is equal to dx. Here this is dw. So this is my value of the Jacobian, that is j, right? So what will be the new function? The new function will be f of new will be equal to what's f of old? That's 1 by 3. In place of x, let's write under root w by 2 and the power is 7. E raised power minus in place of x square write w by 2 why w is greater than 0. So this is my new function. Now we need to find the distribution of this new function. See, let's write it again. That's f of, let's suppose f of w, that's equal to 1 by 3. 1 by 3. Oh, we did a mistake again. So see, into Jacobian, so see, 1 by 3 under root w divided by under root 2 raised power 7 e raised power minus w by 2. What's the value of Jacobian? That's 1 upon root 2 root w. So this is simply f of w is equal to 1 by 3. This is w 7 by 2 divided by under root 2 or simply 2 7 by 2 into 2. As you know, root 2 into root 2 is root 2 square. Square root cancel. This is equal to 2. E raised power minus w by 2 divided by under root w. So now this is 1 by 3 w 7 by 2 minus 1 by 2 e raised power minus w by 2 divided by w 7 by 2 into 2. See, the options of this question is in chi-square. So let's make it in the form of chi-square. So what is the chi-square PDF? That's 1 upon gamma n by 2, 2n by 2, e raised power minus x by 2, x n by 2 minus 1. So we have w, we need wn by 2 minus 1. So let's write this as 1 upon 3 into 2. Then this is my can I write this as, wait a minute, this is 2 7 by 2. Yeah, this is correct. 7 by 2. Wait a minute. This is 3 into 2. Then this is 2 root 2. Is our Jacobian correct or not? 1 upon 2 root 2. Clear? This is 1 upon, oh my god, so this is 2 root 2w. This is 2 root 2w. So see, this will be equal to 3 into 2 into 2 raised power 4 w, 7 by 2 minus 1 by 2 plus 1 minus 1 e raised power minus w by 2. So this is 1 upon 3 into 2 2 raised power 4 w. This is something like 8 by 2 minus 1 e raised power minus w by 2. So this will be equal to, can I write this as, this is equal to gamma 8 by 2 2 8 by 2 w 8 by 2 minus 1 e raised power minus w by 2. See what I did here, 3 into 2 is 6, gamma 8 by 2 is equal to gamma 4 which is equal to 3 factorial. So 3 factorial is equal to my 6, right? So 2 8 by 2 is equal to 2 raised power 4. So this is 2 raised power 4, and omega or w 8 by 2 is equal, 8 by 2 minus 1 is equal to w 4 minus 1, that is w3. So if you calculate this, this is my 7 by 2 minus this is 6 by 2, that's 3, plus minus cancel, this is w3. So w3 is equal to, so from this PDF we can say this will follow that 2x square will follow chi square with 8 degrees of freedom. So n is here 8, this is my n, this is my n. So chi square n, chi square 8, right? This was the question from the last lecture. So now the question that I am going to discuss is one of the most beautiful and interesting question. So let's be focused. That's the question from Iit-Jam exam. It was in 2025. So the question is, let x follows normal 0, 9 and y follows normal 0, 4. Find variance of z is equal to 4x square plus 9y square. And this is question 1. And part 2, find probability 4x square plus 9y square that is less than 6. So in JAM 2025 only B part was asked, but find the variance too. So see, let's write that at x follow normal 0, 9. Is it correct? So x square divided by 3, or simply x divided by 3, that's x minus mu upon sigma. Sigma is 3, follows normal 0, 1. This is standardizer. So x square divided by 3 square, x square divided by 3 square will follow chi square 1, and y follows normal 0, 4. So y divided by 2 will follow normal 0, 1, and y square upon 2 square will follow chi square 1. So simply x square divided by 9 plus y square divided by 4, this will follow chi square 2 with the additive property. Clear? With the additive property. So if I do one thing, that is, let's write this as z is equal to 4x square plus 9y square divided by 36. That will follow chi square 2, which will follow exponential 1 by 2. So variance of z will be 2n, that is equal to 2 into 2, that's equal to 4. Or we can say variance of z is equal to 2 square, that is 4. 2 square from exponential distribution and 2n from chi-square distribution. Clear? Now first part is done. Now second part. As you know, probability 4y square plus 9x square, sorry, 4x square plus 9y square is less than 6. Let's do one thing. Divide by 36. That's x square divided by 9 plus y square. Uh, Let me write this again, that this is equal to. Can I do one thing here? Wait a minute. Can I do one thing here? Uh, this is the question that 4x square plus 4y square. Wait a minute. Let me check the question again. Let me check the question again. Yeah, this will also follow chi-square too. But let me check the question again. 9x square. This is 9x square. This is 9x square. This is my 9x square plus 4y square. This is 9x square plus 4y square. Simply, this will also follow the chi-square. This will also follow the chi-square. So, divide by 36. This is equal to x square upon 4 plus y square upon 9 is less than 1 by 6. So, x square divided by 4 plus y square divided by 9 will also follow chi-square 2, will also follow exponential 1 by 2. Now, probability, let's write this as z is less than 1 by 6. So, this is the CDF of, what is the CDF of exponential? That's 1 minus e minus x by 2. Clear? So in place of x, write 1 by 6. So this is equal to 1 minus e raised power minus 1 by 12 is my correct answer. Or you can do simply one thing. What's that one thing? Say probability z is less than 1 by 6. As you know, z follow chi-square 2. What is the PDF of chi-square 2? That is 1 by gamma n by 2, that's 2 by 2, 2 by 2, that's n by 2, e raised power minus w by 2, w 2 by 2 minus 1. Now, what is the range? What is the range? Range is from 0 to 1 by 6. This is 1 by 2, e raised power minus w by 2, dw. So simply this is equal to 1 by 2, e raised power minus w by 2 minus 1 by 2, 0 to 1 by 6. So this is equal to 2 by 2 minus e raised power minus 1 by 6 into 1 by 2 minus e raised power minus 0, that is 0. So minus 0, that is 0. So this is equal to 2 cancel, minus e minus 1 by 12 plus 1. So this is 1 minus e minus 1 by 12. So हमने ये क्वेश्चन कहां से किया? एक तो किया काई स्क्वायर से और एक किया एक्सपोनेंशियल 1 by 2 का CDF लेके. क्लियर? सो आई होप कि ये आपको समझ आया होगा. एंड डू वन थिंग, watch the lecture again from the beginning after making the notes. जब आपने नोट्स बना लिए इन दो क्वेश्चंस के, then do one thing, फिर से एक बार गो थ्रू हो जाओ इन दो क्वेश्चन से, क्योंकि ये इंपॉर्टेंट क्वेश्चन है. दिस इज द इंपॉर्टेंट क्वेश्चन, क्योंकि IIT-JAM 2025 में आया हुआ है, पूछा हुआ है ये क्वेश्चन. इसको फिर से आप करो, ठीक है? इसको आप फिर से करो. Now see, here is the theorem. The theorem is, let x1, x2 up to xn are IID exponential variates with parameter with parameter lambda. Then prove that 2 lambda summation xi, where I is equal to 1 to n, will follow chi-square to n. So we need to find this. So see, क्या करेंगे हम इस क्वेश्चन में? Simply x follow exponential lambda. Clear? What will be the PDF of x? That will be equal to lambda e raised power minus lambda x, where x is greater than 0. Clear? Now see how to solve this question. What is the MGF of this? So that is lambda minus t. Clear? Where this is also equal to 1 minus t upon lambda raised power minus 1. So where t by lambda is less than 1. Clear? This is the MGF of this. Now let's find the MGF of summation xi. So y is equal to 2 lambda summation xi, where xi's are IID. See, xi's are IID. So what's myt? That is simply m 2 lambda summation xi t. Clear? In place of y, we simply write 2 lambda summation xi t. And as you know, the constant term gets multiplied by with this t, so this will be equal to m summation xi into 2t. So this is equal to 2 lambda t. So this is equal to product of m xi 2 lambda t. Clear? Now if xi's are IID, this product will be written like this: m xi 2 lambda t raised power n. As the reason is xi's are IID, we can write this like mxi 2 lambda t raised power n. It gets multiplied n times. Clear? So as you know, the MGF of this, that is equal to 1 minus 2t, as 2 lambda, that's 2t, minus 1 raised power n. So this is equal to 1 minus 2t minus n, and this is the MGF of chi-square to n. This is the MGF of chi-square to n. Clear? So we can remember this as, if x follows exponential lambda, then y is equal to minus 2 lambda summation xi will follow chi-square to n, or simply y is equal to 2 upon lambda summation xi will also follow chi-square to n. This is not minus here. So this is when x follow exponential lambda, and this is when x follow exponential 1 upon lambda. So in this, what is the PDF? PDF is 1 by lambda e raised power minus x by lambda, and here lambda e raised power minus lambda x. So what is the mean of this? That is 1 by lambda, and what's the mean of this? That is lambda. Remember this, right? Now see another question, or simply this is a theorem. Let x1 and x2 are independent distributed, each as chi-square variate with 2 degrees of freedom. Show that density function of y is equal to 1 by 2 xi minus x2 is g of y is equal to 1 by 2 e raised power minus mod y, where y is between this and this. So see, the transformation, the technique of transformation will be failed in this case. That we have the chi-square, only one PDF, that's the chi-square. How we can write the joint distribution? We cannot write the joint distribution of x1 and x2 because x1 and x2 is itself chi-square 2. The PDF will be only in terms of single variate. But here we have the two random variables. So that is solvable but difficult. So we cannot go through the transformation technique. Rather, we can use MGF technique. Simply, when x follows chi-square 2n, then what's the mxt? That is 1 minus 2t minus n by 2. Clear? Clear? Now say what will be the mx1 minus x2 divided by 2t? That will be equal to simply m x1 minus x2 into t by 2. That will be equal to mx1 t by 2 multiply m minus x2 t by 2. So this will be equal to, what's the mxt? That is 1 minus 2. In place of t we can write t by 2 of a single. This is the single variable. This is the n variables, 2n variables. That's the degree of freedom 2n. So this is minus 1 multiply 1 minus, that is plus. As we know, that's m minus x. That's 1 plus 2t by 2 minus 1. This is minus 1 here. So can I write this as 1 upon 1 minus t 1 plus t? So this is equal to 1 upon 1 into 1 plus t minus t square. So this and this goes. So this is equal to 1 upon 1 minus t square. So as you know, this is the MGF of Laplace 0, 1. So that is 1 upon 1 minus lambda square t square. Here lambda square is equal to 1. So g of y will be 1 upon 2b e raised power minus mod of y minus mu upon b. Here b is equal to 1, that's b square is equal to 1 and mu is equal to 0. So can I write this as 1 by 2, as b is 1, e raised power minus mod of y minus 0, that is 0, divided by 1, that's 1. So where y is between minus infinity to infinity, hence proved. Clear? Now see another question. That's let x1, x2 up to xn be a random sample from normal 0, 1. Define xk, that's equal to 1 by k summation I is equal to 1 to k xi, and xn minus k, that's equal to 1 by n minus k summation xi. I is equal to k plus 1 to n. Then find the distribution of k x bar square plus n minus k x n minus k bar square. So see, in this question we are given with we are given with random sample from normal 0, 1, that is the standard normal. And here is x bar, that summation xi divided by k, and xn bar, that's simply xn bar. Find the distribution of this. So simply we can write this as x k bar. As you know, say what you know is that x follow normal 0, 1, then x bar will follow normal 0, 1 by n, 1 by under root n, sigma upon under root n, and this is sigma square upon n, 1 upon n. Variance of x bar will be 1 upon n. So standard deviation of this will be 1 upon under root n. Clear? So see, x bar k minus mu is 0, divided by what is standard deviation of x bar k, that's 1 upon root n, and this will follow normal 0, 1. This will also follow normal 0, 1. Then x k bar divided by 1 by under root n ka whole square will follow chi square 1. Is this correct? Yes. Let's write this as T1. And x n minus k, that's bar, divided by 1 upon under root n minus k will follow normal 0, 1. And this is, let's write this as T2, that's x bar n minus k square upon 1 upon under root n minus k 1 minus k whole square will follow chi square 1. Then T1 plus T2 will follow chi square 1 plus chi square 1, that will follow chi square 2. So x bar matlab this plus this will follow chi square 2. Clear? So this is the distribution of this. So what we did today, let's see. And remember, nobody on YouTube would give you the content like me. You have seen from the previous videos as well. And see, in the beginning of this lecture, we solved a question that was from the last lecture. That's simply in front of you. That's we are given with a continuous random variable with PD of this, then we find a distribution of this by the transformation. Simply, this is the question of transformation. So this is the right option of this is chi square. And this is also asked in your JAM exam this question. Clear? So see, this is simply we make it in the form of chi-square with n degrees of freedom by the transformation. And in the second question that was asked in your JAM exam, that's in the year 2025. That's something like this, and I add up the one more option. That's this option. Find the variance of this. Simply, this is chi-square 2, which is exponential 1 by 2. So the variance will be 4, and this is chi-square 2. We did it by two methods. That's one with the PDF of exponential and one with the PDF of chi-square. So as you know, x follow exponential lambda, then f of x will be lambda e raised power minus lambda x. Then capital F of x will be 1 e raised power minus lambda x. This is the CDF. So we use the CDF technique. And in case of chi-square, we simply write the PDF of chi-square. And then we prove the theorem that's based on the 2 lambda summation x. I will follow chi-square to n. This one. Then we have the theorem that's the this is also the symmetric about 0. This is also the symmetric about 0. Expectation of x will be 0 of this, that's Laplace 0 comma 1. The expectation of x will be 0, mean mode of this mode of x will be 0, and median of x will be 0. As you know, whenever the distribution is symmetric, mean mode median is always 0. So this is the independent distributed chi-square with 2 degrees of freedom. Then we did this question with the help of MGF. Then this is in front of you. Clear? And if I add one more option of this question, that is find the find the find the find the let's make this question as probability x1 minus x2 will less than 0. See, it is the symmetric about 0. The probability will be 1 by 2. Is this correct? The probability 1 by 2. As this is the symmetric about 0, then the probability 1 by 2. As you know, f of xx minus f of minus x is equal to 1. When this is symmetric about 0, that's f of x0 minus f of 0 is equal to 1. That's minus 0 is 0. So this is 1 by 2. This is f of x plus 1 by 2 is equal to 1. So 1 is equal to 1. So this symmetricity is proved from this, that you know f of x plus f of minus x is equal to 1. That is simply f of x0, that is CDF at 1 by CDF at 0 is 1 by 2, as this is the symmetric. So and in the last question we simply find the distribution of this. By making it standard normal variate, then took the square of that standard normal variate, that becomes chi-square with 1 degree of freedom. That this is chi-square with 1 degree of freedom, this is also chi-square with 1 degree of freedom. So with the help of additive property, this will follow chi-square 2 degrees of freedom.